Are we? Yes, there we go. Hi, everybody. It's glad to be here. Almost full room. Let's see if somebody comes. Great. Okay, thank you for having me. It's my first time in Istanbul, so very welcoming. Thank you for, really, thank you for having me. There is a little something there. Sorry, let me fix that. It doesn't work? It's good? There is a little glitch in my screen. Sorry, guys. Still there? Still there. Do you like that little icon, like rainbow icon there? I can keep it. Okay, good. It doesn't look good. Okay, anyway, I'm Alex. So I am a developer, and today I want to tell you a little bit about serverless applications and safe deployments. So before we get there, I need to tell you a little bit of what do we mean by serverless and what do I mean by safe deployments. So a little background about me. I'm a web developer, software engineer. I have a data science development background. I'm really passionate about serverless, if you didn't know this yet. I'm also one of the organizers of Serverless Days. I've been a customer of AWS, and that's why today I'll be showing you a little bit of what you can build with these technologies on AWS, but most of the concepts hold in a multi-vendor, multi-cloud world as well. So before we get started, how many of you are familiar or know about some concepts about serverless or at least function as a service? Raise your hand. Wow, nice. Very good. So I want to start by saying that function as a service is not all that matters in a serverless world, right? A lot of people get confused about this distinction. So let me get started about what do we really mean about, when we say serverless computing. Basically, when you have function as a service, if we have to say it in 3 words, it's about not managing and not really caring about the underlying infrastructure of your system. Okay, that's in 5 words. What it really means, it means putting one abstraction layer on top of your operating system, your containers, and everything, so that you can focus on what really matters in your apps, which is your code, your business logic, your services, integrations, and everything that really brings value to your customers. So similarly to the way we stopped caring about, I don't know, CPU manufacturing and punch cards in the last 20 years, we now are starting to not care too much about the physical server, the physical machine, and that's the way, we bring a lot of time back into our development pipelines by not managing all that stuff ourselves. So we just delegate it to, could be your internal ops team if you are in an on-premise organization kind of setup, or it could be a cloud provider if you are in the cloud. And that's one thing, so not caring about the machines. But since you don't care about the infrastructure, it means that whoever is managing their infrastructure is doing a lot of work for you. It's doing monitoring, it's doing auto-scaling, they're doing all sort of things. So today I want to show you how you can build on top of this abstraction layer to go and deploy in a safe way, and we'll get there. So it doesn't mean that you don't have to monitor anymore. It doesn't mean that you don't have to instrument your applications anymore. It's just that you care about the application layer, not the hardware infrastructure layer. So you still have to adopt your culture. You still have to adopt your processes. So everything we have seen today so far still applies. It's not a brand new world where we just forget about everything. All the best practices apply. Another very good advantage of serverless is that you can stop paying for idle compute capacity, which we don't really care about anymore. If you have a server or a machine or a container there waiting for something to happen for like 6 hours, and you're still paying for that compute capacity. And that doesn't happen anymore in a function as a service, especially if you are in the cloud, because you're just not charged when nothing happens, which is really great. And also all the high availability and the fault tolerance properties that you want to have in your system are kind of built in into this function as a service. Because you don't have to think about how many data centers, how many regions, or in the AWS cloud, how many availability zones do you have to use in order to be highly available and to be fault tolerance in case of hardware failure, network failure. You know, all of that is built in into the service. So if you check, you know, the cost by the minute or by the second or by the millisecond, you might say, okay, it's a bit more expensive than EC2, isn't it? But that's because you get all these functionalities and all these features by default, right? You don't have to care. Okay, the whole data center goes down, your service is still up because we just deploy it to multiple availability zones, multiple data centers at the same time. Another point that a lot of people forget is that serverless is not just about function as a service, it's about making sure that you can build in an event-driven fashion. So you stop thinking about deploy an agent or your code into a container and connect all the wires to the network. You can forget about that and think event-driven. You want to run your code when something happens in your system, when there is some event to store somewhere, when there is a file uploaded or a file updated somewhere, when there is a new record in a database. Whenever something happens in the system, you want to run a little piece of code that does something and reacts to this event. And that's a mindset change. That's a application design change. It means that, yes, some of the tooling that we developed in the last 20 years are not as useful anymore, like those big full stack frameworks that we really like, because they give us a lot of features. That's not the way you do microservices, right, anyway. So this really aligns to the microservices approach to build very small things that do one thing really well, that here are the same. And so you have event sources that generate events that happen in your system. You have functions, cloud functions, we say Lambda functions in AWS, that run your logic and react to events. And since you can run any code in most of the, let's say, the major programming languages, depending on which platform, you know, you can integrate any other third-party service or API or even legacy kind of service as well. So it's not that you have to take everything you have and throw it away. You can integrate everything. You can build a full system or add new features to a legacy system in a serverless fashion. What other use cases that we see most of the time? Well, we talk about, of course, web applications, a lot of backends for IoT kind of systems, or web mobile applications, of course. We see a lot in the data processing space because when you think about data, a lot in the data world happens in an event-driven fashion. There is a new event to be stored, there is a new record, a new database update. These are all kind of events that happen in your system, and you can react to them with a serverless function. There are other very interesting use cases like chatbots, or even conversational interfaces like Amazon Alexa, for example, or Amazon Lex. So all those scenarios are backed by a serverless backend, usually, because when you ask something to a chatbot, that's an event. You can react to it in a almost stateless fashion. So that's a very good use case too. Another set of use cases is about IT automation. So all your cron jobs, all your let's say compliance checks can be reorganized as a serverless function. So you don't have a server running 24/7 just to run a bash script once a day or twice a day. You can just pay for those 5 minutes of cron job and forget about the server thing. Okay, let me tell you a little bit about the patterns that we see with this kind of new approach. A very interesting point about using functional service is that you are free to bring your own code. And that's not just bring your own code, like lines of code. That means bring your own language. That means you can have a multi kind of language team that develop a full system using, I don't know, you like Java, you like Node, I like Python. We can work together in a big system, in a big API web service, for example. That's not impossible with other non-serverless, in the non-serverless world. It's just harder to maintain all these different runtimes and different dependency systems and blah, blah, blah. The resource model is very simplified. You know, you don't select instance types or stuff like that. You have like a power handle. How much powerful do you want your function to be? And I call it power. Most clouds call it memory, RAM. But also remember that if you raise the RAM, the memory, you also raise the CPU, and you usually also raise the network capabilities. So you can think of it as a power handle. So if you have CPU intensive, RAM intensive kind of workloads, you know, you can go up to 2 or 3 gigabytes of RAM and up to a couple of cores. So you can do a lot even in your data processing or in the machine learning space, for example. Let me tell you about monitoring and logging. You know, that's all built in as well. If you operate in the cloud, you want to have in Amazon we call it CloudWatch. So everything that you log inside your code, like print or whatever you use, console log in Node, all of that gets automatically centralized into the CloudWatch log stream, and you can monitor that. And each individual function has its own metrics. So how many invocations, what the average latency, what's the average duration of your code running, what's the error rate, what's the throttling rate. So you have all these built-in functionalities that you don't have to rebuild yourself. And there are many events that you can listen to. Let's say listen. You can think about data events, like there's a new file, there's a new database update, for example, or there is some real-time stream of data coming and you want to process that stream, or maybe there is a, I don't know, more like high level, like a new user sign up. Have you ever wanted to do something when a new user sign up? Okay, you can do that. That's an event too in your system. Or something more related maybe to your HTTP endpoints. You want to have a new event when there is a HTTP request, or maybe when there is a MQTT request in the IoT world, like bidirectional invocations between a device and your backend. You can do that. Or maybe you want to orchestrate different functions so that you have a full state machine, like a full pipeline that does something more complex than just one invocation of 10 lines of code. All the way to, you can react to events like there's a new Git push in your GitHub repository. Okay, you want to react to that and do something useful. Or, you know, all sort of things. And not to mention message queue, email hooks, pub subtopics. You know, those are all subsystems of your big architecture that generate event, basically. And these hold for any cloud. I want to show you, these are the AWS corresponding services that do this for you. But you know, basically you can integrate anything you want as well, since you have API endpoints, since you have a native way of invoking the Lambda function from anywhere in the system, even if you are on premise, right? So the execution model is a bit complicated at first. You need to understand there are different ways of invoking serverless functions, especially Lambda functions. There is the typical synchronous scenario where you maybe have an API endpoint and your function will need to generate the response and return it. That's super simple, right? And that's synchronous because you can't just return anything until you have generated the response and the client is there waiting for a response. But then there is the asynchronous model where there is something happening, like a new file on S3, or I don't know, a new record in the database again, or a new message in a message bus. And the client is done writing that event or that message. There is some buffer in between, and then your Lambda functions will be invoked. This is a nice decoupling mechanism, so that you know who generates the event and who processes the event are completely decoupled. This is what we call a synchronous invocation model. And there is a third one, which is very similar, but it's stream-based. So you want to have a stream, meaning, a set of records, a set of updates, not just one, and process them in a batch fashion. So that's really similar. It's asynchronous. You still have decoupling, but instead of processing one event, you process 100 or 500 of them. So this is a different model of using your functions. And then you have the typical modern application world in which you don't have one function. Maybe you have 2 or 3, still doable. Maybe you have 20 of them, and they all talk to each other in a microservices fashion. And in that case, Maybe some of them read or write to a database. Maybe some of them are invoked by a queue or by an API gateway or by any other trigger that I showed you. So this modern serverless application becomes really hard to manage, really hard to monitor, really hard to kind of understand what's going on if you get hired tomorrow and you look at the console or at the code or at the YAML configuration templates and blah, blah, blah. So yeah, maybe some of them even talk to legacy systems, so that becomes black magic. So we recently, I think last year, released an open source language to define kind of like a state machine. How many here are familiar with the state machine concept? It's basically a few, right? So it's basically a way to define a flow, maybe with conditions, maybe with branching, maybe with loops or retry logics that allow you to orchestrate your function in a better way. For example, last year I built this project that I called it the Lambda function, the Lambda power tuning project. So the problem I had was I had no idea how to choose the power of my Lambda functions. How powerful should, given a random Lambda function, given any Lambda function, how powerful should it be? Well, I built a data-driven approach to solve this problem with a state machine. So you give me your Lambda function input, I do n parallel branches, run your Lambda functions enough times to have statistically relevant data, and then at the end of the state machine I can tell you, okay, this specific Lambda function with this input event that you provided should be should have this power configuration. And that's based on cost, performance, and different logics that you can configure. So open source project, check it out. Okay, let's get to the real topic of today, which is safe deployments. The real question is, in any scenario, in any use case that we saw so far, how do you reliably update your code to a new version that is possibly stable, might not be, right? If you're here today, it's because people put bugs in production. I'm a developer. I've done that so many times, and it's fun because you want to be fast. You want to be experimenting. You want to be faster than anybody else in your market, and that means you have to release new stuff as soon as possible, right? The business really like it. The problem for us, the like infrastructure, the like architecture and monitoring and security, is how do you do that reliably without breaking everything every night, right? So let's agree on what I mean by safe. There are many things that you can do to make a system or a project or a team safe. You can start with do a lot of pair programming in your team. You can add some unit tests, good practice, right? You can do some local integration tests, maybe add some code reviews, so you have pull requests and that kind of stuff. You can have continuous integration, so that every time you push or you update your code in your Git repo, it gets built and everything, depending on the runtime, on the language. Okay, you're really cool, you add some continuous delivery, so maybe this stuff gets up, deployed into some pre-production or dev environment. Maybe you have some pre-production integration tests, so it actually uses the actual services and third-party integrations. You test everything end to end, and maybe you have some semi-automated human tests run by humans, and maybe you even get to continuous deployment. So you get all this stuff into production at every single push. There's a lot of stuff to do, but things still break. It's really tough, and you don't want to get into that situation where even if you have done all of that, you have a bug in production, and you have to wake up at 3 a.m. and there are people on call in this room, I'm sure. So you don't want to be that guy. And sometimes you're really good. You get to that level. You get to this level like, yes, I can do everything. But sometimes doing that after all these efforts, getting woken up at 3 a.m., it feels more like this. You feel super powerful, and it just doesn't work. So let's agree on how we can make it safer in a, let's say, managed, reproducible way and very safe way. So this was a typical, let's review the basics here. This is what a typical CI/CD pipeline looks like. You have a build phase, a source phase, where you store your code and you get updates from developers. You build it if you need to build it, if it's Java or a compiled language. And usually with a continuous integration logic, you stop there. You just build it. It's ready to be deployed somewhere. If we have a continuous delivery, you want to be able to get to production, but maybe you have a kind of a human step, a kind of acceptance gate before you actually do it. The real magic will be to go to deployment, continuous deployment. So every push gets to production, or at least the pre-production stage, right? This is how, this is the service that allows you to do it on AWS. Some of these might be replaced by like open source tooling or third-party services. You might have GitHub instead of code commit. You might have Jenkins instead of code build. You might have your own development tooling for the testing phase. Today I want to focus on the last phase that allows you to go all the way to production. Whatever you used before in all the other phases, whatever pipeline you have built, you with your own tooling or with the AWS tooling, I want to show you what you can do today to get to the safest possible deployment strategy. If that's not enough, we have some customers that build open source project to basically build step functions. The state machine logics that I showed you before is managed by another service called AWS Step Functions. So some of our customers build their own very, very custom state machine to manage this kind of deployment. That's also an alternative, not simpler. I want to show you the simplest possible way. So how many here have heard of AWS SAM, the serverless application model? Raise your hands. A few. Nice. So SAM, besides being a nice squirrel, is a, let's say, an extension of CloudFormation. CloudFormation is how we do infrastructure as code in a managed fashion within the AWS platform. So SAM is an extension that allows you to go from this like 500 lines of CloudFormation YAML templates to maybe 15 lines. So it's an extension that takes your simplified template and expands it or transforms it into the long version. So it does a lot of magic for you. It's open source as well. So you can fork it, customize it, redeploy it, and use your own SAM 2.0 if you like it. So it allows you to define functions in a very convenient way. It allows you to define events also in a very convenient way. If you maybe are familiar with the serverless framework, it's a kind of a similar syntax. Let's call it syntactic sugar maybe. I like it. SAM is not alone. It comes also with a local CLI tool that allows you to do local development, local unit testing, emulation of the AWS Lambda environment in your machine. So you can work offline. You can do all sort of local integrations before actually git push, unless you like to git push and see what happens. This is also open source. I think this is written in Go, if I'm not wrong. Very nice project too. So let's see how we can raise this kind of safety bar. And I want to tell you about what do we need, or in the end, what we actually built already. So what do we need? What did customer ask us to build? So we wanted to keep the infrastructure as code best practices. We didn't want to have some magic that nobody has no idea where it comes from. So all we want to do is maybe add a few lines in our infrastructure as code. We want to have this automatic and kind of smart monitoring. We want to have a very nice way to, maybe a dashboard, to monitor what's going on. We want to have many different data-driven strategies to do this kind of deployment. I'll show you what this means in a second. Maybe we want to add some hooks to do our own customization, maybe to send an email, a Slack message somewhere, or to do some pre-deployment additional integration tests eventually. And the most important thing here is that we want to be able to automatically roll back if there is any error based on the features above. So I want to have monitoring, I want to have alarms, I want the system to automatically go back to the previous version. So I get push, something bad happens, let's make sure we can go back automatically. Automation is key, right? So I want to tell you about the AWS Code Deploy. Code Deploy traditionally was used to deploy into servers, into machines, into EC2, for example. So this is very recent. I think this was announced in December last year, less than 9 months ago. So this allows you to integrate the, let's say, the new weighted alias traffic shifting capabilities of AWS Lambda, so that I don't know if you're familiar with an alias. An alias in Lambda is like a, you can call it dev or prod, for example, and it points to a specific version of your Lambda function. So when you update the prod alias to the new version, it's like a pointer. So we introduced this weighted alias feature that allows one alias to point to two different functions, two different versions of your function in a weighted way. So you can say 50% of the traffic goes to the first version and 50% goes to the new version that I just uploaded, for example. So this allows you to do like canary or blue-green kind of deployment. Another interesting feature of this new integration is that it allows you to do pre and post deployment integrations or hooks or triggers. So before the deployment starts, you can run another Lambda function, and after as well. So you can integrate your, I don't know, third-party tool, or send an email again, or send a Slack message, for example. And about the data-driven strategies, you have a few options. I don't know if you can read it. Yeah, possibly. So you have, for example, you can do canary, or you can do linear deployment, meaning, for example, you want to do, I don't know, 10% every 1 minute. That's a nice strategy. I want to git push a new version. 10% of the traffic is allocated to this new version every minute. So in 10 minutes, my deployment is over. If everything went correctly, no rollback is needed. If at some point there is an error, I can roll back safely. So let me show you what it looks like. This is the dashboard that is available to you as soon as you deploy a new version. So this is the very beginning. So we have 90%, 10% allocated. You have different phases, like different steps, like pre, during, and after deployment. If everything goes right, you'll see the percentage go up, maybe 60-40, maybe 50-50. At some point, you'll get to 100. So this is the best case in which nothing goes wrong, hopefully. But we wouldn't be here if nothing goes wrong ever. So I want to show you a real example of what happens when something goes really wrong. So let me show you. Okay, so here I have my template. It's a YAML template. Sorry, it's a bit small. It's a YAML template. It contains a table. It's a dynamo table. It contains one function. Doesn't do much. It's bound to a /test endpoint that I'll be polling. And here I have added a few lines that allows me to configure the linear 10% deployment strategy, 10% every minute. And I am monitoring these two alarms. So two alarms that are triggered if there is any error with a new version or with a new alias. So let me show you. I have a couple of scripts that basically poll the function. Let me go back to the terminal. Okay, good. So I'm now polling this endpoint. It's a public endpoint. Don't DDoS it, please. So I'm not polling this function maybe every 1 second. And I have another script that's tailing the output. So let me show you what's, okay, it's just message okay every second, more or less. Not too bad. Let me show you what happens. Okay, this is the code, very simple. So it's not doing much, it's just querying the database. It's like just a database get into DynamoDB, but it's not important. I want to show you what happens when something goes wrong. So let me add a line. It's good enough to generate a very nice error. Throw a new error. That's good enough, right? It's a big bug. So let's go back, and since we like to live dangerously on stage, I'm skipping all the best practices, all the CI/CD. I'm just deploying to production. Let's see what happens. So now the local CLI tool is deploying straight to production because we like. Let me show you what happens in the terminal, in the AWS console. This is CloudFormation, and let's refresh here. In a second, it will show us, the code deploy dashboard. So here's the dashboard. We should be already allocating 10% of the traffic. Is it working? It's not working. Yes, so it's 10% of the traffic, 90% to the old one, as we would expect. And we are already in the traffic shifting phase. So let me show you. We would expect more or less 10% of the invocations to be an error, because we just deployed throw new error to production. So we have some internal server errors, because it's serverless, but you know, we like to do internal server error. That's the best message ever, I think. Anyway, so yeah, more or less 1 every 10 invocation is failing right now, and we expected that. We just pushed the bug to production. What I expect to see in roughly a minute is that code deploy will notice that the alarm is triggered, and we'll be able to automatically shift back to the safe, stable version. So we are in the allow traffic phase. It's in progress. Let's give it another 10 seconds maybe. Let's go back. Okay, it's still failing once every, yeah, more or less 10 invocations. 10% of the calls are failing. Let's go back. Okay, we just rolled back 100% to the previous version. We have a deployment stopped error in here. The status code is alarm active, meaning, okay, some alarm was activated, and we instructed the system to roll back as soon as possible once the alarm is triggered. So let me go back. There is no error anymore. Let me clear and show you some statistics about the logs that I've been polling. So I have another script that shows some stats. So more or less 9 calls during this roughly 1 minute failed. It's a bit less than 10% because we started polling before deploying. But roughly 9 calls failed. We are now 100% back. Let me show you the CloudFormation. Console is now being updated. We are rolling back. Let's see if we, yeah. So in another second, let's refresh up here. Okay, rolling back. Thank you, CloudFormation. So we rolled back successfully in maybe 90 couple minutes, let's say. So, as we were saying, in a typical regular scenario, you would have all the unit tests, code reviews. You know, this kind of bug would never go straight to production, right? So maybe it will not fail 100% of the times like this. Maybe you have a very subtle bug that fails 1% of the time, and you allocate 10% of the traffic to it, meaning you have 1% error rate. In some very big kind of load scenarios, like for example at Amazon.com, we do this with 0.0001% of the traffic to the new version. That's good enough to see if there are any errors during 1 or 2 minutes. And you're not forced to use 1 minute. 10% every 1 minute. You can allocate different timing logics, different percentage logics based on the load, based on the team, based on the critical properties of your system. And that's all. We deployed the bug to production, we rolled back, and that's all for me today. I hope you had fun.
Thank you, Alex. So we've got a couple of questions coming from our conference app, SiliconConf.
We have time for a question? Not much.
I think we have 3 questions. If you can, answer them quickly.
Okay, so we have a big one. Can we build our private serverless world, or should we use third-party services? Well, so my take on this, my personal take on this is you can build your own function as a service on-premise, but there are projects that allow you to do that, like OpenFast or OpenWhisk, absolutely. I think that's not completely serverless, in my opinion. That's a function as a service on-premise setup. But as I was mentioning at the beginning of my presentation, serverless is not just the function as a service part of it. Serverless means you can actually stop thinking about scaling your infrastructure. Even your DevOps team can stop thinking about that. And you can, I think the most important part is that you can think in an event-driven fashion. So if you build your own fast, maybe you don't have integration with all the other services that you integrated. So if you have enough time and resources to build native integrations with your other microservices to think to think and develop in an event-driven fashion, absolutely go for it. Is that what you want to do? In my perspective, it should be built in within the platform. So it's great to think of functions when you deploy, but when you develop. But if you don't have all this integration, it's basically just an abstraction layer on top of the compute, but it's not fully serverless.
Thank you.
Second question: can we use serverless in heavy CPU works or workloads? I guess. Absolutely. The limitation you have that I didn't mention today is not the amount of compute capacity you have. You can actually now get up to 3 gigabytes of RAM, up to 2 cores. So it's fairly powerful. That's what our customer asked. So they wanted to run heavy data processing or machine learning workloads, for example. They need a lot of RAM and a lot of CPU. Eventually, GPU will come. Eventually, you will get even more compute capacity, compute power. The limitation I didn't mention is the time. So right now, you have about 5 minutes maximum execution time, which is good enough for a lot of CPU-intensive workloads. Maybe it's not good enough if you have, I don't know, 2 million images batch processing kind of use case. But again, you wouldn't do that. You wouldn't do 2 million images processing in the same Lambda. Maybe you want to distribute that and have 2 Lambda functions in parallel. 2 million Lambda functions in parallel do that for you. So it's more about how do you rethink of the use case to make it serverless ready. But yeah, you can absolutely run CPU-intensive workloads. What about prices of serverless tech? Okay, I didn't stress much the pricing point today. Basically, when I said never pay for idle, okay, so when there is 0 compute, 0 events happening, you pay 0. That's very cool, I think. When there is something happening, you pay by 100 milliseconds interval based on the memory that on the power that you allocated. So that's like a proportional kind of pricing. If you have, I don't know, 128 megabytes of RAM, you spend very little. If you double that by the same time of computation, you spend twice as much. It's very proportional. What else? Also keep in mind that choosing the smallest RAM configuration is not necessarily cheaper because it will take longer. Since you pay by the amount of milliseconds, if you take the instance type like the runtime power that is 10 times more powerful, it might take 10 times, it might be 10 times faster. So in the end, you might spend similarly, or it might actually be cheaper. We have examples of CPU-intensive loads that are much cheaper with the largest power configuration. So that's why I built the Power Lambda, the Lambda Power Tuning project. So you can do a very data-driven kind of reasoning on that, and you don't just guess. That's that's my suggestion. Okay. Thank you very much again.
So if you have, we have still like a couple of minutes. So if you have 1 or 2 questions, maybe. If not, we will continue with Ignites. Thank you very much, everybody, for joining us today.
If you have questions.